6.2 Volume by Revolution. Take a minute to read the two essential questions. What we're going to be doing here is estimating the volume by taking a look at little pieces. Let's take a look at these volumes. To find this volume, you find the area of the base and then times it by the height. For a cylinder, find the area of the base, which happens to be a circle, times it by the height. For a rectangular solid, find the area of the rectangle and times it by the height. This is how we're going to look at our little pieces of volume when we start. Our little pieces of volume will be sometimes sideways instead of going up like I had it in the previous picture, but this is our base. And our base could vary, but the representation for the base will be the same. Our width will be delta x. Let's go to the exploration to look at this. This is a picture of the square root function, 2 square root of x. And what we're going to do is we're going to take some rectangles. I'll take 4 rectangles, and I want you to notice that I'm going to revolve them around the x-axis. I'm going to do that one more time. Revolve it around the x-axis. If I increase the number of rectangles, then I will be increasing the number of cylinders, and again revolving it, each one of them going around. As you increase the number of rectangles, you increase the accuracy of the volume. Alright, so let's take a look at finding the volume of a sphere that we learned in geometry. So I'm going to make a rectangle right here, and I'm going to revolve it around the x-axis. When I do that, I create a very short cylinder that we call a disk. This is going to be the radius. Alright, so let's go ahead and take a look at a representation for the volume. The volume will be the area of the base times the height. Our base is a circle, pi r squared, and our width right here is delta x. So that will be our height. Now the radius is the y of the curve, quantity squared, delta x. Let's go to this. Now this is a circle, x squared plus y squared is equal to r squared, and when I solve for y, I'm going to have r squared minus x squared. So this will be the representation I put in for the y of the curve. Root r squared minus x squared, quantity squared, delta x. Let's go to the next slide to see how I finish the problem. Now you can see that I'm going to make the Riemann sum, the limit of all of these disks, and then I'm going to change it into an integral. Now what I've done is I've found the volume from here to here, and then I'm just going to double it. That makes my integration a lot easier. Now we're integrating with respect to x. I'm not sure why I put a y right here. And then I'm going to find the antiderivatives, use the second fundamental theorem of calculus, and then you can see I get my result right here. Alright, let's take a look at another problem. And you can see the rectangle right here. And we're going to revolve it, and that creates the disk, and here's my radius. And this is going to be my y of the curve that will help me get my radius. So delta b will be equal to the area of the base times the height. This will be a circle, pi r squared, and the width right here is delta x. The radius is y of the curve, quantity squared, delta x, and here is my y in terms of x, so that's going to be root x, quantity squared, delta x. Let's move on to the next slide so you can see how I finish the problem. And I go on to the integral, and I integrate with respect to x, so I go from 0 to 1, and I find my answer. Okay, let's take a look at a problem where we revolve around the y-axis. So my disk is going to be going around in this direction. The height of my disk will be delta y. So a small piece of volume will be equal to the area of the base times the height, pi r squared, and my height is delta y. This will now be the x of the curve instead of the y of the curve. And I need to solve for x, which they do right down here. So that'll be pi times y to the 1/3 power quantity squared delta y. Let's go on to the next slide to see how I finish the problem. And I have this. I set it up in my integral, and the y's go from 0 to 8 here. 0 to 8, and then I just go ahead and integrate. Okay, your turn. Take a minute to do 7 and 9. I'll show the answers to those on the next slide. And here are the answers. Now do 8 and 10. Stop the screencast and try that. And here are the answers. Let's move on to finding volume revolved around something other than the x or y axis. So I'll try to revolve around y equal to 2. So that I can see the solid a little better, I'm going to reflect. So I'm going to take a minute to reflect. And so I can kind of get the feeling of what the solid looks like. And I'm going to go ahead and draw my rectangle, which creates my disk. And my radius will be right here. That'll be my radius. So a little piece of volume will be equal to the area of the base times the height, which is pi r squared, and my height will be a delta x. Now the radius will be right here, so this is going to be the y of the upper, and right here will be y of the lower. The y of the upper is always the number 2, and the y of the lower is right here, is root x, quantity squared, delta x. Okay, I'm going to continue. So then this will be over x between, and it looks like it's between 0 and right here at this point, we know this is the point 4 comma 2, so this will be 2, and my volume will be the integral from 0 to 2 pi, and this will be 2 minus root x quantity squared delta x after I take the limit of the Riemann sum. Okay, here's another problem. I'll go ahead and get you started, and I'd like to see if you can finish. We're revolving around y equal to 1. Go ahead and draw your rectangle. And this is going to create, I guess I should have done the reflection here. And that's going to create a disk that looks like this, where the radius is this. So delta V will be equal to the area of the base times the height. The base is a circle, and this height will be a delta x. So the radius will be the y of the upper minus the y of the lower, quantity squared. That'll create my radius times delta x. The y of the upper is always 1, and the y of the lower is right here, x squared, and then quantity squared, delta x. Now the x's are going to go from -1 to 1, so I can choose to go from -1 to 1, or because the volume is symmetric, I'm going to go 2 times the integral from 0 to 1 pi 1 minus x squared, quantity squared, dx. And I think on the next slide I show the same thing. And again, you can go from -1 to 1, or you can double your volume there. Okay, I'd like you to try one on your own. Go ahead and revolve around x equal to 1, which is this right here. Stop the screencast and see what you can do. And here is the answer.